I wanted to take the time to talk a little bit about the concept of camera mapping. Camera mapping has been discussed quite a bit lately since the release of the Michael Arias Animatrix movies. So I wanted to take the opportunity and create a camera map for this image here. It's an arbitrary image I pulled from Jansen's History of Art book. You may recognize it as Pisa, the baptistry cathedral, and the tower in the background here. I thought it made a good choice for one reason, in that we had no knowledge of the photographer taking the picture. We have no idea of the height of him or her. We have no idea of the lens, the amount of distortion that was in the camera lens that the photographer used. So there are a number of variables here that we need to ascertain on our own in order to do an accurate camera map. A camera map is just taking a simple 2D image, such as the one we have here, and mapping it onto 3D geometry in such a way that we can actually move through the 2D image. We have a limited degree of motion, but we can still create the illusion of movement, which often saves a lot of money in production. One of the visual cues in a potential camera mapping image is the use of right angles in the image. We know that this building is more or less built at right angles, 90-degree angles, in order to create the box shape. What we can do is take a grid or a cube or anything that has right angles on it as well, and match up the amount of distortion. The greater the degree of distortion we see here, in other words, the closer we get to a right angle, a perfect right angle, the lower the degree of lens we'll use in XSI. So as we get closer to a right angle, we get closer to an orthogonal, or to no perspective at all. So I've got a grid, and I've moved it into position here, and I'm just going to size the grid up a little bit. So we'll go with some pretty large numbers here, because the set feels pretty large. And I'll just up the number of subdivisions on my grid so I can get some idea of the perspective distortion here. The other thing that we can use is the camera properties. If we go to the camera properties, we get an idea here of how open the lens is, or how closed the lens is. So as we get closer to 0, we get a more forced perspective, until we get all the way to an ortho type perspective here. And then as we go outwards, the angles converge in such a way that they almost become parallel. We get such a wide perspective that we can almost see a 180-degree field of view. So our value that we're going to use, the lens that this photographer used, is going to lie somewhere in the middle, and it's our job to find that. So I'm going to zoom in a little bit here. I'm just going to take this grid, make sure it's the right length, just frame it down here, and we're going to play around for a little bit. So I'm going to try and match this up. I'm going to use the right angles right here, and I'm going to try and match the grid as best I can by eye. There's no real trick to this, it's just a lot of dirty work. So you're using your zoom tool a lot. As well as your orbiting. So a lot of O, a lot of L, you may be controlling the horizon line. And you're going to keep working at this here until you think you've matched the angle up properly. And what I'm doing is I'm taking account into the angles, say right across here. So it's making a right angle, say in this quadrant of the grid here, and I'm trying to match that up with the amount of distortion I'm seeing here as well. Of course, you have to realize that this point is a little bit higher, but again, it has to be taken into account. So again, you can zoom in and out till you get that value correct. And it doesn't have to be perfect at this point, but it should be close. I've gone ahead and I've figured out the best position for my placement grid at this point. And so we'll just call it right there. From this moment on, we can begin fitting all of the other pieces in, and the amount of distortion that they have will be taken into account, obviously, by the lens that our 3D camera is using, and it should fit into the shape of the primitives in the image. And again, the idea here is to use primitives, so I would be using a torus shape here, or not a torus shape, a cylindrical type shape here with a cone at the top. I'm using a lot of rectangular shapes in here, and of course a tall cylinder for the tower itself. I've got a wall on the left side that I also need to worry about, so we'll use sort of a modified cube to create this area here. So let's get into it. I've gone ahead and brought a cube into my scene, and I've made sure of two things at this point. First off, if this is the grid that runs the entire length of my scene, I'm going to take my cube and I'm going to make sure its center is aligned on the bottom. Any scaling I need to do needs to happen from here. Second thing is that I don't want this cube to get any bigger anymore. Or not any bigger, I don't need it to rise off the ground. And this is the ground, negative 32.399 has been defined as my ground plane. So I'm going to pin it into position there. That's in the y-axis. I want it to remain free to move in the x and z. So Control K to activate the local transforms, and we tab on over to position limits. And I'm going to activate the y minimum and maximum. And we'll say negative 32.39. And do the same for the maximum. So now this object is never going to lift off the ground, which is great. So I can go and move this around anywhere I want now, and it should fit in to my image. So I'm going to start by moving it back to the baptistry, or to the cathedral, or to whichever one, to the cathedral. I guess this would be the baptistry here. And I'm just going to size the cube up a little bit. So I don't want to lengthen it because that's going to push it through the ground. Here I just want to scale it. So if I size it up appropriately here, it should more or less match the perspective distortion we see in the image at the corners. And you can see that it doesn't do too bad a job. It isn't lined up properly with the roll of the image, but again, it's not bad for a starting point. And again, for the most part, this process is merciful in that we can get away with a little bit of error. But of course, the better you make this, the more seamless the image will look. So I'm just going to frame it here, and I'm going to move the image down near the base and scale it up a little more. So you can see that we're very close in the amount of distortion we've used. So I'll go with something like that. So the distortion matches pretty closely. We just have a little bit of a raise here. So I could work with the image a little bit more and work out the amount of distortion here as well. So if I was to spend a little bit more time zooming, readjusting the image, so there we go, I'll just zoom in a little bit. So if we go into the properties, you can see that I've actually just decreased the field of view by about a degree or so. The image possibly works a little better there. So you're always balancing everything out. Don't always assume that you're going to have the image work for you on the first try. So we can work on that for a little bit, but I'll keep on going on here. You just want to duplicate the rough form of the building now. So we can see very clearly that the structure begins to scale in a little bit. And we'll pull it up. Duplicate again. And pull it in. So there's a rough of our building, and you can see it more or less stands up at the moment. Again, things don't have to be completely perfect. After tweaking around with the initial primitive, I wind up with a fairly decent structure that represents our image, and I can fit it back in by storing a camera position here. So that's the first portion of the image that I need to fix. The next thing I need to do is add in a cube to represent the T section of the cathedral. So I can start off by getting myself another poly cube, matching its translation to the already existing primitive structure, and you can see just how small the cube is in this scene. So I'll start off with just a rough length to get it roughly into position, and I can use the right view here to line up my structure. Again, I'll make sure that the center pivot, I could just tag some points here and run center to vertices on it. That's probably going to be the easiest way. And then wherever I scale it from, again, it's going to be scaling from the ground up. I don't really need to worry about the X scaling at all. So there we go. We have something looking like that. The next thing I need to put in here, and I may need to make the scale of this object a little larger, say to about there. The next thing I would need to look at is putting in this dome structure at the back, and for that I could use really anything. I'll start off by taking a cylinder, and then I'll add some edges and modify it. So we can again match translation to this background object here, and our cylinder is a little bit small once again, so it's up to us. I'll start off with a radius of 100 and maybe a height of 100. Once we move this into position, again, the perspective should match up as closely as possible to the original, so I probably need to do a little bit more scaling here. Make sure again we can run center to vertices to get our center down at the bottom, so now when we scale, we're scaling from the base. And there we go. I would add some more edges in and create this rounded structure. But the texture maps we apply are really going to aid this process a lot. So again, if it's not perfect, it's not such a huge deal. The last thing that I need to sort of match up here is the baptistry itself in the foreground. So again, we could start off with a very simplified cylinder structure. I'll just frame that object. Run some center to vertices, and I'll begin to scale it. So we'll just set a really high number as our scale, and of course we're also going to have to work with the radius as well. So if I hit enter, I'll say 200. That's probably going to be a little bit too large, but by the time we move it into position, it might fit our needs perfectly. Again, having a top-down view of this structure or this building structure would be extremely helpful. So we just keep on tweaking with the values until it more or less matches the perspective. Again, I would add some more detail in here to get the look I'm after. Notice that the perspective still isn't matching perfectly. We are losing a little bit of perspective in the foreground image here. So again, I would just keep on working the image, and I'd keep pulling at it until I find that perfect point where the perspective of the 3D image or the 3D primitives matches the perspective distortion in my 2D image. After playing around for a little while longer, I've come up with this. Again, the correction in the perspective isn't completely fixed yet, but it'll do for the purposes of this demonstration. Notice how the foreground elements, the poles here, also have their own primitive object, and we're going to create a texture map for each of the objects in the scene. One of the other things I've done is I've added a backdrop, which is going to basically take into account anything above the horizon line. So the background hills, the dwellings in the far background, and of course the sky. I've got an element for this wall running along the left side of the image here, and once we've got all of our geometry in place, so we have our Scene Explorer that basically takes into account an object for each element we see in the picture. If we take a look at our rough scene, we have our ground element, and then at a 90-degree angle we have our BG element right here, which is our sky plate. Again, I would probably take care to match up the ground level here. You can see that we have a couple objects not quite fitting on the ground properly, so I would just want to make sure that I just pull down that geometry so it does at the very least intersect with the ground. Any gaps that appear in the ground could result in rendering error, and so we can do the same thing with these objects as well. But because these objects are very close to us in the foreground and we're going to be moving into the image, I may not have to worry about them, at least not initially. I could try raising the ground a little bit more if I wanted to, or I could try and bring these post elements down a little further. So it could just be a matter of tagging the points and just really making sure that those posts fit. If we finally switch back into a shaded mode, you can see that this is the way my scene lines up. The next part involves a lot of Photoshop work. You need to take your original image, so the image that we're dealing with right here, and we need to split it up into layers. What we're trying to do here, and I'll just take all of my 3D elements and hide them, what we're really trying to do is create a separate file for each element in our picture. So I will create an element, a picture for the ground, a picture for this mid-ground building, a picture for Pisa, a picture for the sky plate in the background, a picture for the baptistry, a picture for the wall, and a picture for all of these post elements. And what we need to do is create an accurate alpha channel for them. So this tutorial isn't about Photoshop, but what I have done is I've gone in and I've created all of the separate elements. I'm just going to open up an image clip viewer here, which should already have my test image ready to go. The trick with the camera map is, since we are doing a 3D camera move through a 2D image, we're going to be revealing a lot of what's being occluded by our foreground, midground, and background geometry, or background images. So we have to imagine what the camera can't pick up. So for example, what would be behind this building here? Well, we would see the continuation of the wall. We would of course see some extra detail in the sky, and we can also note that there are some far background buildings here, so conceivably these buildings could continue on behind this building. Same thing goes for what's behind the cathedral object. Obviously the cathedral is partially blocking the Tower of Pisa, so we would have to paint in the rest of Pisa, and usually you make use of your cloning brush and your stamp tools to achieve this. We've got some people here that we need to paint out, and so in the end I've created alphas for each of these images. So I've got my background building with alpha, and you don't have to be completely accurate unless you're of course dealing with film medium where everything is scrutinized because of the pixel detail. But if you're doing broadcast, for example, you can get away with a lot. We may not be looking at what's behind objects for very long, so I've painted in as best I can here the remainder of the Tower of Pisa. It's not perfect on the left side, but the camera move is never going to completely reveal the building anyways. If we look at the foreground building, again, whatever's white here has been knocked out. We've got an alpha channel in here, and we've isolated the building itself. With the ground, again, I've done as best a job as I can, and I painted in a rough approximation of what I think is going on behind the foreground building. So I painted in the rest of the clouds here. They're a little bit sloppy because of time constraints, and I painted in some extra buildings. Again, if we just keep on moving through, we've got the posts, and we've got the sky, which has an alpha channel cutting off the ground, and the wall itself. So now it's just a matter of applying these separate pieces to our primitive geometry. Depending on what you're trying to get out of the scene, the next step can vary a little bit. We've taken the initial camera and we've matched up the perspective, the distortion of the camera, as best as possible to what we think the photographer used in his settings or her settings on their own camera. Right now I've got my camera and it's set up perfectly, and what I want to do is I want to duplicate and reuse this camera and its position, and I'm going to texture map the images that I've split up in Photoshop and project them onto the geometry. So this initial camera route here, or this initial camera, I'm going to eventually use this one to do the moving. So this camera here is going to serve the purpose of doing the camera move. If I could spell properly. So I'm going to take the entire route as a branch and I'm going to duplicate it. And so we actually see the camera, its visual icon appear here. I can just turn off 3D cameras and we'll just rename this camera. So this camera will be for the foreground building, and this one will be for the foreground building interest. Again, if I branch select this camera, duplicate once again, this one would be for the midground building, and of course we have the interest as well. The reason we use different cameras for each object here is that we may need to do small perspective corrections when we go and try rendering this scene out. If I place all of the images and I project them from the same camera, if I need to make any corrections, say for the foreground building, then it's going to throw off what I've done for the midground, the background, the sky, the ground, the walls, the post, etc. So having a unique camera for each element in your scene can really help you down the road. So go on and duplicate as many cameras as you have elements that need to be mapped. After a little bit of work, I've gone in and duplicated all the cameras I need. Now I need to gather all of the elements that are going to use the same camera to project the image onto. So for example, all of these posts are going to receive the same camera projection because they all share the same portion of the image. So we're just going to start grouping the elements. They're going to receive the same texture map. So here we have building 2. We'll just make sure we group it. And go through and group all of the elements. Okay, so we have the background here, which is represented by the sky plate and the ground plate. And finally we have the wall here. Again, I could apply these materials to the object themselves, but since I'm going with groups, I'm just going to keep it consistent throughout. So let's begin the mapping. I've got my reference in texture decal mode, and the first thing we're going to map here is going to be this foreground building. So I'm going to select building 1. I'm just going to start off by giving it a Lambert. I'm not going to worry about the color. And as far as the image goes, the alpha is going to cut out the image. So any of the detail that we see in the top of the spires here is going to use the alpha to give us the detail. So in order to use alpha channels most efficiently, we can use a ray tracing node and we can use a sprite. I'm going to take the sprite, and the sprite is going to replace the surface and shadow plugin that the Lambert was taking up on the material node, and I'm going to take a texture and plug it into the sprite's input. Now the sprite's built to handle alphas automatically, so we don't need to strip the alpha out and pipe it into the transparency node of, say, a Lambert. So I'm just going to go right to the image node, new from file, and there's our foreground building with alpha. Again, we notice that it is an RGBA image. Okay, so there's the alpha channel there. Okay, as far as our projection type goes, we need to project from a camera's point of view. So we're going to texture projection, new, and we're going to use the camera projection. And from here we need to choose the appropriate camera. So building 1 root, we open that up and we find there's the camera there. If the image doesn't map on perfectly, we can take the building and again we can shift it over until all the elements match here. And you notice we do get a little bit of distortion. So up at the top here, I could probably work at tagging some points, and perhaps in global COG mode just work at fiddling around with the image a little bit more until I get the look I want. So something like that would probably do well enough. So we're going to keep on working here. Open up the Scene Explorer. Let's go and map in the background. So if we take the background, we just start off by giving it a default shader, a Lambert. We'll replace the Lambert again with a sprite into the surface and shadow, and then we'll plug a texture into the input of the sprite node itself, and we're getting a bit of a default grid pattern here, so we'll replace that with the background image. So there's our Pisa background. We'll just say OK. So everything maps in nicely there. And again, we'll make sure that we use the appropriate projection. So new camera projection, and this time we can use the background camera right there. You'll see that by default it did take the initial projection that we had, which was the projection from camera 1. So we just keep on moving through here and replacing the Lambert with our sprite. So I'll do one more building here. We'll use building 2. Building 2, we'll give it a Lambert. Open up the render tree, replace the Lambert with the sprite through the surface and shadow connections. Image node into the input of the sprite, and finally replace the image here. So the no icon picture ends up using building 2, and we'll make sure we give it a unique camera projection here. So building 2, there we go. And you can see how everything's starting to come together. When everything has finally been mapped, the initial camera that we used to place our primitive geometry, so in order to match up the perspective distortion in the 2D image, we're going to reuse that camera, and we renamed it Move Me Camera earlier on. So I'm actually going to be taking this camera now. Again, we want to make sure that we actually switch to use the appropriate camera, not one of the cameras that's projecting a texture map. And this is the camera that gets animated. So I've gone ahead and I've got a camera interest path curve as well as a camera path curve, and they're just slightly offset from one another. And I've basically just taken the Move Me camera and I've used the Set Path tool, and I've done the same thing for the camera interest as well, and just animated a slow camera push in. So in texture decal mode, our alphas aren't cut out, but you'll notice if I zoom in here, I can get quite a bit of movement out of our image. So I'm actually moving right into that image there, getting the illusion of a 3D camera move, and all this out of a 2D picture. So not too bad. Again, we couldn't move too far in this image. We're limited to what we see within the border of the image. So we can't pull out from here. All we can do is move into this image. So it's good for initial establishing shots with a slight truck in, things of that nature. I've gone ahead and done a little bit of a render so you can see how the camera map project ended up looking. And it'll play a little bit slow because of the Camtasia software running in the background, but you'll notice, I'll just turn it off play here and do this manually, that we do get the detail in the edges along the top here, though they are a little bit blurry. That's more to do with the limitations of the photograph I used. Using a photograph from a book tends to pick up the grain in the book as well, so you can see that when we do get close, this image was scanned at a maximum res of 1024 by about 769. So when you start moving in too close, the image does start to break up. But the amount of motion we get out of this is quite impressive. We do get a lot of camera movement out of this. So this is the basic concept behind camera mapping. taking a 2D image, guessing at the positioning of the photographer, guessing at the lens the photographer used, and recreating that scene in 3 dimensions. The nice thing about this is if you have a high-resolution digital camera or a traditional analog camera, you are able to take images at a much higher resolution, thus getting a lot more out of the image than we have here. So I guess a lot of you may be digging up a lot of your old vacation photos. It'd be fun to camera map some of them. Maybe you've been to South America, some of the pyramids at Chichen Itza or in Egypt, for example. But really, this does save a lot of money in production and is quite a handy tool, saving a lot of work. So that's the idea behind camera mapping. I hope you enjoyed this tutorial.